All right, well, welcome to the final exam review for Math 1332, Liberal Arts or Contemporary Mathematics. Let's get at it. Okay, so in this first question, we are referring back to our fallacy lessons. I have gone ahead and supplied you with all the possibilities of this. So keep in mind the two examples that we're going to look at are just two examples. All 10 of those are worth going back and reviewing, since those all could be fair game. You could be asked to identify those. So let's get to the question. It says, for the following argument, describe one or more of the fallacies. Okay, so my first job is to describe. So in other words, identify what it is, and then explain the fallacy, explain how it's involved. In other words, what is it trying to say? So there's two answers to each of these statements. Probably one of the biggest mistakes I see students make is they don't read the question carefully enough to figure out how many answers they should be supplying. All right, so in this first statement, when confronted with questions from the press about alleged political scandals, Congresswoman replies that the allegations against her should be ignored, since her accuser is part of a vast right-wing conspiracy. Well, with today's politics, it's kind of easy to understand that there's a lot of politicians are saying, hey, this guy's a nut job, we should just ignore him or her. So that's kind of mean. So what they're trying to get us to recognize is the personal attack fallacy. And what that means is, or what she's saying is, the Congresswoman is suggesting that her opponent is not right, opponent is not correct, because he agrees with right-wing conspiracy. All right, power of Excel, or of Word. It tells me the spacing, whatever. We'll change that. Okay, so there's the two parts. I've identified it, described the fallacy as personal attack, and made this statement that the Congresswoman essentially explained why personal attack is applied here. Does that make the argument correct? Does this Congresswoman have a point? No. Just because someone might agree with other philosophies doesn't mean that they're incorrect in what they're currently saying. All right, second one. All right, fine, suggesting. Okay. And going back to this, there's a lot of good things that one could say. This is just my sentence, but it's put it in your own words in a way that makes sense. Next statement, television commercial shows two senior citizens enjoying rock climbing and scuba diving and then drinking a certain kind of vitamin drink. Okay, so they are wanting us to feel something as we watch these old people do these fun things that we're not doing. So that's an appeal to emotion. And what the argument is that if we drink this vitamin drink, we can go rock climbing and scuba diving as well, which again isn't the case. Just because you drink something yummy and delicious doesn't mean you have all these abilities to climb rocks and do all these big things. Number two, if you put the following in if Q then P form, then what would not P be? So they're actually saying look for the if part, look for the then part, and negate the P part. Luckily, we already see an if-then part. So if P, then Q does correspond to a part of the sentence, but the word if and then are not really part of P and Q. It's just how we bring up the proposition and the condition or the conclusion of that proposition. So the P part is wishes were horses, and we're asked to negate that. Now, be aware that on the actual final itself, you want to review all this if-then stuff. You could be negating something, you could be rewriting a conditional statement into inverse, converse, contrapositive form. So you want to go back and review all those other things. But specifically in this case, if I'm negating P, sorry, just trying to not show other questions here, then my statement would be just the words wishes were not horses. So I'm not changing the sentence per se to make the word wishes be something else or horses be a different animal. I'm just putting the word not in there. The intention of this question is to review Venn diagrams, specifically how to read it, while in this case I'm identifying specifically what X is. So I'm going to go ahead and answer that, and then I'm going to talk a little bit about some other things that we can read off of this particular chart. So X means the 16 people who play basketball but not volleyball. Now I'm going to just have a quick conversation, go a little bit further in this, because we need to talk about lots of other things that Venn diagrams can do and tell us. So for example, how many students play basketball? And follow that up with how many students play volleyball. And follow that up with how many students play both sports. Okay, so pause the video real quick and see if you can answer those questions. I'm going to come back and answer them myself, and here we go. For basketball, there are two groups. There are just basketball people and both people. So that's 16 plus 3 is 19 people total. Volleyball is a similar setup. So there's 9 that just play volleyball plus another 3, which gives us 12. And I've kind of hinted at this the whole time that there are 3 students that play both. So again, you want to review back on Venn diagrams and not just think it's going to be this one particular question. Could be reading a Venn diagram and all sorts of fun things about it. Okay, the tricky part on number 4 here is we need to remember all the different types of Venn diagrams we've looked at. We did break it down into 3 big cases. We talked about the overlapping case, we talked about the subset case, and we talked about the mutually exclusive case. So if we think back to, and by the way, that's what this question is trying to get us to remember, all those different Venn diagram facts. So if we put that all together, hopefully you can kind of see that this is an illustration of one of these 3 different flavors. Keeping in mind in the overlapping case, these are the different flavors of it, but this is the subset case and this is the mutually exclusive case. So based on what we see some S is P, some dogs bite. So we're looking right here where we've got 2 subsets where we're told that we have Chihuahuas are a dog, so we're told something is in this subset right here. So in honesty, this is our picture. So I'm going to kind of copy this and get rid of all this other stuff. But you do want to review the different types of Venn diagrams that we've looked at in this course. Okay, so now that we're staring at the specific illustration of this, our specific question, and again, you don't want to think, oh, he's just going to ask this. But our question is about what can we deduce from this. And about the only thing we can say, because I don't know, I know Chihuahuas are in the dog circle. I just don't know if they're in the bite circle or not in the bite circle. Let me try that again. I don't know if they're in the bite circle or not in the bite circle. So about the only thing we can say is that some Chihuahuas bite. That's kind of off screen. Some Chihuahua. Why did I have to pick a... The word is right there. Some Chihuahuas bite. It's about the only safe thing that we can deduce from something like this. But again, you want to review Venn diagrams, review how to read them, how to interpret them. Don't just focus in on the one category that I'm practicing with you here.